This section of the notes is complex conjugates, and for those of us that did regular Algebra 2 last year, this is new. We didn't do this in regular Algebra 2. Pre-AP Algebra 2 did do complex conjugates last year, so this should be a little bit of review for you. Complex conjugate is used to get rid of imaginary numbers in the denominator. So let's just start off figuring out how to find the complex conjugate. If you have 3 plus I, all you're going to do is you're going to change the sign of the imaginary part of the expression. So 3 plus I becomes 3 minus I. 5 minus 4I, change the sign of the imaginary part, becomes 5 plus 4I. Okay, that's how you find the complex conjugate. So what we're going to do now is we're going to take our 3 plus I and we're going to multiply it by the conjugate, and by doing that what's going to happen is, like these examples up here, your imaginary number, your i's are going to cancel out and you're going to be left with just a number, and there's a purpose behind that. We're going to see that here in just a minute. So when we multiply these together, we're going to have 3 times 3 is 9. Well, that's going to be negative 3i, and that's going to be positive 3i, which will totally cancel. And then the I times negative I is minus I squared. Well, I squared is negative 1, so that's 9. 9 minus negative 1 is 9 plus 1, which is 10. I's are completely gone. 3 plus I times 3 minus I turns out to be 10. Okay, let's try this one. 5 minus 4i times 5 plus 4i. Oops, I. Alright, 5 times 5 is 25. Again, this 20i and this negative 20i will totally cancel out. Negative 4i times negative 4i is negative 16i squared. I squared is negative 1. So 25, negative 16 times negative 1 is positive 16. 25 plus 16 is 41. So by multiplying by the complex conjugate, we get rid of the i's. Now let's see why we need to do that and where this comes in. Okay, here's the reason why we have to find or be able to find complex conjugates. Just like you're not supposed to leave square roots in the denominator, okay, just like you're not supposed to leave something like that with a square root in the denominator, and you have to multiply by the square root of 3 to get rid of it, you can't leave i's in the denominator. So something like number 12, you are not supposed to leave an I in the denominator. So what you have to do is you have to multiply the numerator and the denominator by the complex conjugate, which we just got through figuring out how to find the complex conjugate back here. Okay, you have to multiply by the complex conjugate so that you will get rid of the I in the denominator. So figure out what is the complex conjugate of the denominator here, not the numerator, but the denominator. The conjugate of the denominator would be 2 plus I. Remember, change the sign of the I, the imaginary part. Whatever you multiply the denominator by, you multiply the numerator by the same thing. So let's just multiply, distribute. That's going to be 4 plus 2i. I can have i's up here, I just can't have i's down here. So multiply these together. That's going to be 4 minus I squared. Alright, everything up here is fine. I can leave that alone. Okay, remember that I squared is negative 1. So this ends up being 4 minus negative 1, which is 5. And now I have simplified that. No i's left in the denominator. See, I just have 5, just have a number now. So I have taken care of that. I've gotten rid of the denominator having i's in it. So let's try number 13. Same thing. What is the complex conjugate of the denominator? That would be 3 minus 2i. And whatever you multiply the denominator by, you multiply the numerator by the same thing. Alright, let's multiply here. 5 times 3 is 15. 5 times negative 2i, negative 10i. Distributing here, negative 9i and positive 6i squared. Okay, down here at the bottom, that's going to be 9 minus 4i squared. Alright, let's take care of our I squares. I have one here and there. Okay, so this is going to be 15. 6 times negative 1 is negative 6. 15 minus 6 is 9. Put those i's together. That's minus 19i over 9 minus negative 1. No, 9. It's going to be 9. Negative. About that. 9 plus 4. There we go. Because negative 4 times negative 1 is positive 4. 9 minus 19i over 13. Now, none of these simplified, but like if 9, 19, and 13, if all those divided by the same number, like 2 or 3 or something, then you would need to simplify those. But that wouldn't simplify anymore. So, that's it. You're good to go on that one. Okay, last example is solving using quadratic formula. So we're going to plug into the quadratic formula, and it just so happens that our answer is going to have i's in it. So your quadratic formula is x equals negative b plus or minus big O square root sign b squared minus 4ac, all of it over 2a. A, b, and c. Alright, so x equals negative b plus or minus big square root sign b squared minus 4 times a times c, all over 2 times a. So I just plugged in the formula. Let's go through here and simplify. X equals, that's positive 2. Negative 2 squared is 4. Okay, be real careful with your signs here, because this is negative 4 times 3 times 5. That's going to turn out to be negative. 4 times 3 is 12, times 5 is 60. So 4 minus 60 over 2 times 3 is 6. So x equals 2 plus or minus 4 minus 60 is negative 56 over 6. Okay, so I have a couple of things happening here. I have this right here that becomes an I on the outside. I also have 56, which will simplify. 56 is 4 times 14. So let me erase that I a little bit. Okay, so the square root of 4 is 2. And I'm going to have an I for the negative. So outside the square root sign, I need 2i. Then I have square root of 14 on the inside. The I is from the negative sign, and the 2 is from the 4, and then the 14 stays inside because I can't take the square root of 14. And all that is over 6. Now, at some point, sometimes you're finished here, but this one will simplify just a little bit more because the 2, and the 6 are all divisible by 2. So divide all of these by 2, and you're going to get 1 plus or minus. You don't have to put the 1 right here, but I'm going to put 1i square root of 14 over 3, Or you can write it as 1/3 plus or minus 1/3 I square root of 14. Okay, you can leave it as one big fraction, or you can split it up. Either way, but you do need to reduce the 2, the 2, and the 6. Okay, so either one of those would work for your answer. And that would be it for section 2.